Have you ever wondered what exactly a point in geometry is? It's a question that might seem simple at the surface, but when you delve into it, it opens up a world of abstract thought and mathematical philosophy. In its most basic definition, a point in geometry is a precise location or place within a given space. But here's the catch. It has no dimensions, no width, no height, no depth. It's not something you can hold or touch or see. It's an idea, a concept. It's like the dot at the end of the sentence, but even that dot, small as it may be, has dimensions. A true point, in geometrical terms, is infinitely small. This dimensionless nature of a point might seem like a paradox. How can something exist without dimensions? Well, that's where the beauty of abstraction in mathematics comes into play. A point doesn't need to physically exist to have a purpose. It's a tool, a marker, an anchor in the sea of space that helps us understand and navigate the vastness of the universe. Think of a point as the most basic building block of geometry. Without points, there would be no lines, no shapes, no space. Everything in geometry, from the simplest line to the most complex shape, starts with a point. It's like the zero in numbers, a seemingly simple concept that forms the backbone of all numerical systems. But this understanding of a point wasn't always the case. The concept has evolved over centuries, shaped by the minds of ancient thinkers and modern mathematicians alike. It's a journey that takes us from the concrete to the abstract, from the physical to the conceptual. So we established that a point is a dimensionless entity that marks a specific location in space. But how did we arrive at this understanding? Well, to answer that question, we need to delve into the history of mathematics and the philosophical questions that have shaped our understanding of this fundamental concept. But that, my friends, is a story for our next scene. Our understanding of a point in geometry didn't come out of nowhere. It has a rich history dating back to ancient times. Our journey begins with the ancient civilizations of Greece and Egypt, where the foundations of our modern understanding of geometry were laid. These civilizations saw the world in a way that was fundamentally geometric, and points played a central role in this vision. To them, points were not just abstract entities, but rather tangible markers of space and location. The Greeks, in particular, devoted considerable intellectual energy to the study of geometry. Their work was underpinned by the idea of a point as the basic unit of space. For them, a point was the beginning of everything, the seed from which all other geometric concepts grew. One of the most influential figures from this era was Euclid, a mathematician whose work, Elements, became the cornerstone of geometrical theory for centuries to come. In Elements, Euclid defined a point in a simple yet profound way. He described it as that which has no part. This definition, though seemingly straightforward, was a revolutionary concept at the time. It encapsulated the idea that a point, despite having no physical size, could still exist and have a meaningful impact on the world of geometry. This concept of a point as an entity without size but with location laid the groundwork for the development of more advanced geometrical theories. It allowed mathematicians to conceive of lines, planes, and volumes, all of which can be understood as collections of points. Euclid's definition of a point was not just a mathematical proposition, but also a philosophical one. It challenged the notion that something must have physical size to exist. This philosophical shift opened up new avenues of thought, not just in geometry, but in other fields of study as well. While Euclid's definition was revolutionary, our understanding of a point has evolved significantly since then. As we delve further into the mathematical philosophy of a point, we'll see how this ancient concept has been refined and expanded upon, shaping the way we perceive and navigate the world of geometry today. As time passed, our understanding of a point became more refined and complex. During the Middle Ages, a subtle but significant shift occurred in the way we thought about points. The ancient Greeks saw points as an abstract concept, but scholars in the Middle Ages started viewing them as more concrete entities. They began to emphasize the role of points in defining lines and shapes, which signaled a move away from the philosophical to a more practical understanding of geometry. Then came the Renaissance, a time of great scientific and artistic awakening. Artists began to experiment with perspective, creating paintings and drawings that gave a sense of depth and three-dimensionality. This was a game changer. Suddenly a point wasn't just a dot on a flat surface. It became a spot in space, a fixed location in a three-dimensional world. And this new understanding didn't just revolutionize art, it had profound implications for mathematics as well. The concept of a point as a location in space opened up new avenues for mathematical exploration. It allowed mathematicians to think about points in relation to each other, to consider the distances and angles between them, and to visualize them in three-dimensional space. This shift in perspective was a crucial step in the development of modern geometry. For the first time, we were able to move beyond the flat, two-dimensional world of Euclid and explore the complexities of three-dimensional space. The introduction of perspective in art had a profound effect on mathematical theories about points and space. It forced mathematicians to grapple with new questions and challenges, and it paved the way for the development of more sophisticated mathematical concepts and techniques. One of the most significant outcomes of this evolution was the introduction of coordinate systems. This was a revolutionary concept that allowed us to map points in space, to assign them specific coordinates that indicate their precise location. This opened up a whole new world of possibilities for mathematical exploration and discovery. This evolution of perspective paved the way for the introduction of coordinate systems. With the advent of coordinate systems, points took on a whole new significance. No longer were points merely the abstract building blocks of geometric shapes, but they became something tangible, something we could pin down, something we could identify with precise accuracy. This leap forward in understanding was largely due to the introduction of Cartesian coordinates, named after the French philosopher and mathematician René Descartes. Cartesian coordinates provided a framework that allowed us to locate points in space with incredible precision. Imagine a point floating in space. Before Cartesian coordinates, this point could have been anywhere, and we would have struggled to describe its exact location. But with Cartesian coordinates, we can give this point a home. We can place it on a grid and give it an address. This address comes in the form of a pair of numbers, known as coordinates. The first number tells us how far to move along the horizontal axis, the x-axis, and the second number tells us how far to move along the vertical axis, the y-axis. This ability to assign coordinates to points revolutionized the concept of a point. It brought a level of concreteness and clarity that was previously missing. A point was no longer just a dot on a page, but a specific location in space that could be identified and studied. This shift in understanding had profound implications, and it played a crucial role in the development of analytic geometry. Analytic geometry is the study of geometric shapes using algebraic equations and coordinate systems. It allows us to describe complex shapes such as curves and surfaces, using simple mathematical expressions. This wouldn't have been possible without the concept of points and their newfound relationship with coordinates. Yet, despite this newfound clarity, the philosophical questions about the nature of points remained. Though we now had a new way to identify points, the philosophical questions about their nature remained. Points may now have a precise location, but what are they? Are they physical entities, or are they purely abstract constructs? These are questions that continue to intrigue us even as we delve deeper into the mathematical universe. Even with all these advancements, the philosophical questions about the nature of points are still a topic of discussion. Let's delve deeper into this fascinating discourse. The nature of points has been the subject of philosophical debates among mathematicians for centuries. Some view points as purely abstract entities, figments of our intellectual imagination that exist only in the realm of mathematical theory. They argue that points are conceptual tools, used to help us understand and navigate the complexities of geometric relationships. However, this is not the only perspective. Others believe that points have a more concrete existence, that they exist not just in the abstract world of mathematics, but also in our physical reality. They argue that points are more than just theoretical constructs, they are fundamental building blocks of our universe. This dichotomy between the abstract and the concrete is a recurring theme in the philosophy of mathematics. It mirrors the age-old debate between idealism and realism, between the world as we conceive it in our minds, and the world as it exists independently of our perceptions. In the realm of geometry, points serve as anchors, as reference markers in the vast expanse of geometric space. They are like stars in the night sky, guiding us through the intricate constellations of shapes and forms. Whether abstract or concrete, points are the bedrock upon which all geometric structures are built. They are the seeds from which lines, planes, and volumes sprout. The philosophical debates surrounding points reflect the beauty and complexity of mathematics itself. They remind us that mathematics is more than just numbers and equations. It is a rich tapestry of ideas, a grand narrative that explores the deepest mysteries of existence. So whether you view a point as an abstract entity or a concrete reality, one thing's for sure: points are fundamental to our understanding of space and geometry.